Welcome to Brain Vision.
In this problem, we have four smooth balls, each with identical mass. A and B are moving with velocity v towards C. They strike C, and C then strikes D. Now, if we know the final velocity of C and D, which is v, we want to know why D will not move off with velocity 2v. So the collisions will occur in the following sequence. Firstly, ball B strikes ball C. And we'll take motion to the right as positive. So using the conservation of momentum, we see that mv, which is the momentum for ball B, remember ball C is stationary, so its momentum is 0, is equal to minus mvb, the velocity of B after it strikes C, plus mvc. So since the mass is identical, we can divide both sides by m and we get v is equal to minus vb plus vc. Now we can also use the coefficient of restitution here and take again the right direction as positive. So E is equal to 1, the coefficient of restitution, and this is equal to Vc plus Vb over the initial velocity v. So essentially we have two equations with both unknowns Vb and Vc. If we solve them, we find that Vc after the collision is v and Vb is equal to 0. So essentially Vb comes to rest and Vc now moves off with speed v. The second collision is ball C striking ball D. And again, we'll use the methods above, taking the right as positive and using the conservation of momentum first. So C moves off initially with momentum mv, and after it collides with D, the momentum is due to C minus mvc plus mvd. So we can write this, if you divide both sides by m, v is equal to minus vc plus vd. Now we'll do the same as we did above. We look at the coefficient of restitution. Again, that's 1. So E is equal to 1, which is vd plus vc over v by definition. And so we can see from here that vc after the collision is now 0 and vd is equal to v. Now the next collision is ball A striking ball B. Using the conservation of momentum, we have A moving at initial velocity mv, and this must equal to minus mva plus mvb. So again, we can divide through by m and we get v is equal to minus va plus vb. So we can see a pattern emerging. Again, the coefficient of restitution E is equal to 1, and this is vb plus va all over v. And so again, two equations with two unknowns gives us that vb is equal to v and va comes to rest, so va is equal to 0. And for the final collision, ball B then strikes ball C. Now again, we'll use the conservation of momentum, and mv, the initial momentum of ball B, when it strikes ball C again, is minus mvb plus the momentum of ball C, mvc. So v is equal to minus vb plus vc. And again, if we apply the horizontal components of the coefficient of restitution, E is equal to 1, and it's defined as Vc plus Vb over V. And so, again, we are left with two equations with two unknowns. We get Vc is equal to V, and ball B comes to rest, so Vb is equal to 0. Now, what we can see from here is that if D rolled off with twice the velocity, 2v, its kinetic energy would be twice the energy available from the original two, A and B. So a half mv squared plus a half mv squared is not equal to a half m2v all squared. So this is not possible.